So we're continuing factoring using a t-table. We have 3z squared minus 11zm minus 20m squared. So now you've got multiple variables, which is a little bit more difficult. But how would you go through this problem?
Well, I'm going to approach it the same way. I'm going to label my coefficients A, B, and C. And for now, we're just not going to worry about the variables. We're just going to do it the same way that we've been doing it. And you'll see that it's going to work out for us. So here we have the A times C and then B. So A times C is 3 times negative 20, which is negative 60. And then B is negative 11. So two numbers multiplied by negative 60 add to negative 11. So first we'll go negative 20 and 3 adds to negative 17. Try again. Negative 15 and 4 multiplies to give us that negative 60 and adds to give us the negative 11. So we're going to use these two and substitute it in for the negative 11zm. So we're going to rewrite it as the 3z squared minus 15zm plus the 4zm minus 20m squared.
So let me just add one thing here. It doesn't matter what order you write these in. So as soon as you get the negative 15 and the 4, the order here doesn't matter, as you'll see.
So we're going to continue and factor by grouping. So we're going to group these two and take the greatest common factor of both. So 3z squared minus 15zm, they share a 3z in common, and are left with z minus 5m. We have 4zm minus 20m squared. They have a 4m in common. So we're going to take that out, and we're left with the z minus 5m. So we look at what we have right now, and we have a z minus 5m as our greatest common factor between the two expressions. So we're going to factor that out, and we're going to have 3z plus 4m, and then our z minus 5m.
So it's always nice when we get to this step and you see that you've got the same common factor, because then you know you did things correctly. Yeah, so it looks kind of scary with the multiple variables, but going through the same process that we're used to, you end up getting the correct answer.